April QAS test from 2019. And the question says, which statement about reflectance patterns in Monotropsis odorata, is best supported by the data presented in Figure 1? So just like in the last question, the way to solve this first is let's go up to Figure 1, make sure we have a decent understanding of what the figure is about. So first thing we need to do is notice that we have 4 things that are being measured here, right? So these are 4 things from the Monotropsis odorata. We're measuring the leaf litter, which is the surrounding environment. We're measuring the bract, which is that outer leaf that's serving as the camouflage. We're measuring the flower petal, which is the flowers, and the reproductive stem, which is the stem of the plant. Then we have on the y-axis here, percent reflectance from 0 to 45%. And then here we have wavelengths from 300 to 700 nanometers. And basically this is saying that as we shine this brighter light, right, with different wavelengths, then we're going to get a higher degree of reflectance, and it gives us the different measurements for these different items on the plant. And the 2 trends that we should notice is that these 2 lines go together, and these 2 lines sort of go together until the end here. So these 2 lines, this is the leaf litter and the bract, and they rise together pretty much the same. And this makes sense because if you remember from the passage, the bract is sort of the mechanism of camouflage that's being used, and the leaf litter is the surrounding environment. So it would make sense to say that these 2 are rising together because the reflectance from both of them is essentially the same. And what this does is it allows the plant to blend in because this outer layer, this bract, is sort of blending in with the surrounding leaf litter, the surrounding environment. Whereas the flower petal and the reproductive stem are this different, brighter, purpley color, and they're sort of rising together, so they're not going to match the environment. That's why we need the camouflage. So we need a statement that's going to match it. Probably just going through them one by one is the best option. So A says the flower petal reflectance tracks closely with the bract reflectance pattern. So the flower petal reflectance pattern, that's this one here, and it's basically saying that this is going to track with the bract, which is not true. So bract is kind of up here, and the flower reflectance is down here. They don't track together well, so we get rid of those 2 and get rid of this answer choice here. B says that the leaf litter reflectance pattern shows decreases in relation to increases in the flower petal reflectance pattern. This basically means that leaf litter needs to be going down, and at the same time, flower petal needs to be going up. So is it true that the leaf litter is going down as flower petal goes up? No, it's not true, because as flower petal is going up, leaf litter is going up as well. And that's really true, honestly, for any of these features that are measured on this. Basically, as all of them are going up together at the same time, there's no increase and decrease, so let's get rid of B. And then we have the next one, which is C, and this says the reproductive stem reflectance pattern is similar to the leaf litter reflectance pattern. So let's go and say reproductive stem, so that's this one here, this dotted line, is similar to leaf litter, which is going to be this one here. And that really doesn't work either. We see that these 2 are sort of separate, so that can't be the answer choice. Let's get rid of those lines and get rid of C. This is going to leave us with D. Let's see if it works. The bract reflectance pattern differs substantially from the reproductive stem. So we go back up here, we have the bract reflectance pattern, which is this one here, differing from the reproductive stem, which is this one here, and there is a significant difference between the 2, so that is going to be our correct answer, and we choose answer choice D for question number 31.